Right, we're here now at the bottom of page 4. The previous video, the battery ran out just as I was saying my last sentence, so sorry that I didn't catch that sooner. But we'll recap what I was saying here before we get started. We just did 2 equations that involved fractions at the top of the page. We're going to redo those same ones. The reason why is because when there's an equal sign, and only when there's an equal sign, when you have an equation, you actually can eliminate the fractions at the beginning. And you don't even have to work with fractions. Now, the answer might still turn into a fraction, but you don't have to work with them all the way through. Now, how do you do that? Well, you're going to multiply every term whether it's a fraction, regular number, variable, not a variable, we multiply every term by the LCD, including what's on the other side of the equal sign, even if it's not a fraction. Okay. Now the catch is, of course, well, not of course, but the catch is it will turn into a 2-step equation. Now that would be a problem if we were only dealing with 2.1 in the way that the book does, and it's only teaching 1 step. We have already practiced all the steps, so we're ready for this. So you can actually use this little trick now, or this tip, I should say. It's not a trick. The reason why we can multiply everything by the same number is because we're keeping it balanced. We're basically multiplying one side by 6, and we're multiplying by the other, multiplying by one side by the LCD, the other side by the LCD. So I jumped ahead here. The LCD in this first one, number 26, is 6. We already worked these problems at the top of the page, so we know what to expect as our answers, so we can determine if we are doing this correctly or not. Let's go. Let me show what that means. It means we're going to multiply both sides of the equation. Okay, so we're going to multiply one side of the equation by 6 and the other side of the equation by 6. In this case, the t plus 2/3 and the negative 7/6. So then we distribute that 6 across here because we can't combine the t plus 2/3. We don't know t yet. So it becomes 6 times t plus 6 times 2/3. We still have the 6 times the negative 7/6 here. And when we distribute, okay, so now when you multiply by 6, again with fractions, if you're struggling with this, please get some extra help. But what happens is the denominators are going to cancel in here, so you get 6 times t plus the 3 goes into 6 twice, and you get 2 times 2 is 4. So the 3 goes into 6 twice because it's like 6 over 1. And then you can go 2 times 2 on the top, 1 times 1 on the bottom. That's just 2 times 2, which is 4. Equals, again, it's like 6 over 1, so the 6 goes into 6, bottom and top cancel, leaving behind 1s, factors of 1. 1 times negative 7 on the top, 1 times 1 on the bottom, that's just going to be a negative 7 on the top. Okay, and now we're looking at a very familiar site here. We're in AX plus B equals C form. We have done our, the distribution has caused it to land in this nice ready to go thing. So let's go through our steps just like we would before. Let's check for parentheses. There's no parentheses, that's already taken care of. Any like terms that we need to combine, we look on one side. Nope, 16/4 are not like terms. Negative 7's by itself, so that's done. We need to make sure t has picked a side. T is just in one spot over on the left side, so we're good there too. So now you get to ask yourself, what is happening to t? And again, we're going to get a 2-step list because of what we did here with the multiplication, and that's okay. We know how to deal with that because of the process we're practicing. So you cover up the one side of the equation that doesn't have t. Imagine putting a number in here for t and ask yourself, what would you then have to do according to order of operations? Well, if you put a number in for t, first thing that happened would it would get multiplied by 6. Then you would add the 4. So our steps are multiply by 6. Our second step is add 4. Or if you were going to do the visual method, you would say, you would start here, I'm starting at t, it then gets multiplied by 6, after that 4 gets added. Okay, so it's a story, it's a timeline that goes left to right here. Then you can reverse that. You want to undo that list. So you want to go back up the list. This is exciting. We've got 2 steps here. So instead of the order being multiply and then add, we're going to go up the list. So this becomes step 1. This one becomes step 2. We still make them opposite. Instead of add, it becomes subtract 4. Instead of multiply by 6, it's divide by 6. Or if you're going to do the visual way, instead of going left to right on this timeline, we're going to go right to left, and we hit every opposite. So instead of plus 4, it's going to be minus 4. After that, instead of times 6, it's going to be divide by 6. So let's go ahead and do that. Follow the list you've just made, just like a prescription from the doctor's office here. Do exactly what they say. Follow doctor's orders here. So you've set this up for yourself. So if you're following this, you'd go from the right, minus 4, then divide by 6. If you're writing it this way, you're going to subtract and then divide. Same thing. Subtract 4 from both sides, so that's where we're going to start. That leaves me with 6t is equal to negative 11. Negative 7 minus 4 is negative 11. So we followed the first step. That's done. Now we do the next step. So going up the list here, divide by 6. That's what it says here too, as we go right to left, divide by 6. So I'm going to divide both sides by 6, and I get t is equal to negative 11/6, which is the same answer we got up above, only this time we didn't have to deal with fractions all along the way. Of course, so since we know that it already works, we've already done that check for negative 11/6 back in the original. So I'm ready just to write that in my set notation. Okay, let's try that one more time. Let's look at what do you do to eliminate fractions from the get-go. First, you make sure there's an equal sign, which there'll be plenty of in this chapter because that's the focus, solving equations. Then you determine what that LCD is. In this case, 3 and 2, same LCD, 6. Okay, and we're going to multiply both sides of the equation by 6 by the LCD. Okay. So what that would look like is you're going to get 6 times the 7/3 equals 6 times the right side. This case, 7/3 negative 5/2 plus z. From there we go ahead and do the distribution or do the multiplication. Actually, I won't do this. Sorry, I thought it was distributing first. We'll wait on the multiplication here. 6 times 7/3 equals 6 times negative 5/2 plus 6 times z. We know the 6z can just be written like that with no parentheses. Now let's do the fraction multiplication. So imagine the 6's being 6 over 1. Do your pre-canceling here. 3 goes into 6 twice. You're left with 2 times 7 over 1 times 1. So that's 2 times 7, 14 over 1, or just 14. 2 goes into 6 once, 3 times on the top. 3 times 5, negative 5 on the top, that's negative 15 over 1 times 1 on the bottom. So negative 15 over 1, that's negative 15. Okay, and now we have our ax plus b equals c form. It's just that our ax is sitting over here. This is our ax plus b equals c. So totally fine like that. This is a linear equation. We haven't changed anything, just the look of it. Okay, so from here, then we start our steps here. We're checking for parentheses, and that's already done for us. There's nothing to distribute. We check for like terms, so we look on the right side of the equation, nothing to combine. The right side of the equation just has 14, so like terms are already taken care of. Pick a side, make sure z is on one side of the equation, not on both, and it is. It's on the right side, so we're good. And then we start our list. So we ask ourselves, what is happening to z? So if you look at z, cover up the other side of the equation. Just focus on the side that has z. If we put a number in for z, what would happen? First, we'd multiply by 6, then we would add a negative 15, or you can think of it as subtracting 15. Those are the equivalent. So the first thing is that it gets multiplied by 6. The second thing is that we subtract 15 from it, or add a negative 15. Either one is fine. Or you could think of this kind of timeline here. You'd start by putting in a number for z, then you'd multiply by 6, and then you'd add the negative 15, or you would subtract 15. Let's write it the other way just so you can see that they're the same. Adding a negative 15. And we go this direction, left to right, as you read through that timeline for what's happening. Finally, you then undo that list. So we go back up, reverse the direction, opposite operations. So when I see subtract, I add. When I see multiply, we're going to divide. Or if you want to use the little visual timeline here, go the other direction as you come to it. Adding a negative 15, we're going to be subtracting a negative 15, which is really just the same as adding 15. Subtracting a negative is the same as adding. So that's why those two are equivalent. Subtracting 15, same as adding a negative 15. Okay, subtracting a negative, same as adding. And then instead of multiplying by 6, we're going to divide by 6. So now go right to left, and this is what you need to do. So first thing, it says to add 15 or subtract a negative 15, whatever makes the most sense to you. Do that to both sides. You should get 6z is equal to 29. So we did that step, Oh yeah, I forgot to say, as we go up the list, this second step becomes a 1. This is your second step here. So you go up the list as you undo it. So then it says to divide by 6. It also says here to divide by 6. So either way will get you the same steps. Divide both by 6, you get 29/6. Or you could write that as 4 and 5/6, however you want to do that. We've already done the check. You can see the example above where we plugged that in. We got the same answer, plugged it in, it does work. So I'm ready to just announce to the world using my little cutesy braces here, my set notation. I'm set on this answer. Here it is. It's a way to kind of, it's a math symbol that means here is my collection of answers, and it's going to be a skill that you're going to want to develop in 1665 so you're ready to use it in your next math classes. Okay, so that takes care of those questions. You try one now on number 30. Take the time to TQC. Tell somebody what you saw. Talk it through for yourself if you have to. Note any questions and bring those to class, and then go ahead and make sure you've got everything copied. That's why the video is here. Take your time. Do what you need to do. Hit pause so that you have a chance to try this one on your own, number 30. And you should end up with a -1/8 as your answer. Okay, good job. We'll see you at page 5.